Hello and welcome to another video tutorial on how to use C++. Today we're going to talk about how to handle digital images. So what we want to do is to design a software structure to handle simple image data, like to first read images, then have access to pixels, and then lastly save the image. Okay, before we start, just a few words on digital images in general. So normally these images are represented in a matrix with image elements. These are called pixels. You might have heard about that. So pixels have a different value to save the color information, and if we take a black and white picture, then a pixel has one value. With 8-bit, we would have 256 different grayscales, in which 0 would be black and 255 would be white. In all, this would make 256. If we would have a RGB image, this would need 3 values to represent each pixel, because every pixel has a red, green, and blue part. But to manage this big data on the hard drive, there are many different formats for images with different compression methods. And the image data normally is read with the appropriate software, but because in here we want to start from the beginning, I chose a very simple image format. This is Pgm. Pgm stands for Plain Portable Gray Map, and it saves the gray values as ASCII text. And if we look at the file, this one is not compressed and it has 1.45 megabyte, which you can see when you hover the mouse over it. So, and if we open it with our image viewer right here, then you can just see the victory column in Berlin. But if we open it in a text editor, you can see the actual format. So this is defined like here. This image format also has a Wikipedia article where a few details can be found. Our format right here is written in the first line, it's P2. The second line then is a comment which says created by OrphanView. The third line is the dimension. We have 512 by 763 pixels. And the fourth line is then the maximum value for one pixel. This is right here. And then starts the single description of every value of each pixel. And then we can see already that the image must be a quite narrow one, because one row only has this amount of pixels. But this is just a specification of the format. And if we want to read this image, then it's not done as a matrix but as a vector. So starting from line 5, we will read every single number until the very end, which is line number 23,600 something. And this is going to be all in a vector. And sometimes lines are longer than others, but this is just because of the definition. You can look this up here, or also in this specification. There it says no line should be longer than 70 characters, so that's why. Okay, so let's change to Visual Studio and close all of this stuff first. And we want to start with a new project that we name 10 read Pgm, in which we want to read images and handle the pixels. So just like this. And as always, we want to have an empty project, and later we add 3 files, 2 CPP and 1 header, and the header and the associated CPP. With those, we start to look at the file format. So first we add a header file, and we name this one, just very simple, pgm.h. And then inside of this header, we first set a comment that says we want to define a user-defined data type to handle grayscale images. Okay, so just as a reminder, user-defined data types, these are our own structures we build. Okay, so to do this, we create a struct, which is just S for struct image. And if we open this, then keep in mind the semicolon at the end of the closing curly bracket is very important. Okay, so the Pgm setup was we have a number of pixels. So for this number we can use an unsigned int. Unsigned because the number of rows and columns cannot be negative. So there's no sign for it, and we can just set unsigned int of rows and an unsigned int of columns. We can comment this here that says this is the number of rows and the second line is the number of columns. And now what we actually save is just in our file. So let's look at this one again. I'm gonna leave this open also in the background. Okay, so we have the rows and columns which just correspond to those in our file, and this is just what we want to read and then save in these variables. Okay, then next we want to ask for our maximum value, so we just create a variable that's named maxval, and this one should save the maximum grayscale value so that we have a definition and just know how many of them we have. Okay, next we need a string for the format of the file. So in this case it's just p2, and this string is named format, and let's comment this also. This is a string to save the file format. We also need a string to save the comment which is written inside of the file, just in the beginning there. So this one is to save comment in file. And we need a vector to save all gray values in this file. So vector of data type short, named gray values, and this is obviously to save all these gray values in a vector. First, we also have to include some libraries, so therefore we type in include. What we have is IOStream, because we want to read from files, and we also need the fstream because we want to work with files. Then we need vectors because we want to have some, and of course strings. So now our struct is finished. This should be enough for the self-defined data types, but now we of course need some functions to work with the image. So first of all, of course, we need a function to read the image, just to get it into work with it. Then we want to ask for gray values at specific positions in the file. So you could imagine that we type in the position of row and column and get back a gray value. This is what this function should do. Also, we want to manipulate the image, so we want to set a gray value, a new one, and lastly, we of course, after manipulating it, we want to save the image. Okay, now we can think about what we need for the function to read the file. So what kind of return value? This should be the image. So we just type in the S image. The function name is readPGM, and we want to assign a constant string to it. So later this should be the file name. And because it's constant, we use the keyword const. Because this is in the header, this should be enough for now. Next we have the gray value function. So the return value here should be short because everything in the vector of gray values is also short. So this is the return value here as well. And we use the function name getGrayVal, and we assign the image, also constant this time, and we assign an unsigned int for rows and an unsigned int columns. Then for the function grayValues, we don't have a return value because we want to write in the vector directly later. So for the function, we just set void. Function name is setGrayVal, and we assign the image, but here we forgot to not only set the data type, assign the data type, but we also need to assign a variable that we use as reference later. So this is just the image. The same can be done here. And next we also need the rows and columns to write the gray value at the correct position. And then of course we need a gray value. So this is just a value, short val. Lastly, we have the function to save the image. So the function name should be writePGM, and we assign the image and a file name. So constant string file name. Okay, so now our header is basically finished. Here should be a space. Okay, so this is finished. We can save it. And next we can add a source file, a CPP file, which has the same name as the header. This is necessary. So we name it Pgm and click add. Now because this part here is just like a function declaration, we can just copy it and paste it to the CPP file. So put it right here. But first, of course, we have to include the header file. So we write include, and then it's already suggested, so we just select pgm.h. And as always, normally we want to use our standard namespace. And now we can start to implement all our functions. The first one is to read the Pgm file. So here we can open this construction. Okay, std we don't need anymore. First we need the data type as image, and we have to set a name for this, which we just set to image. Then we need an f stream to read our file, and this one we just name in. Okay, then we can open the f stream with the function in open, and then we assign the file name and set iOS in to open it for input operations. Then don't forget the semicolon, and as we did last time, we have to check if this was successful. So we type in if not is open. This is the negative form. Then we have the output cout that the file couldn't be opened. And then return image. But of course, normally we assume that this was successful and we want to start reading the file. And to read the first line of it, we use the function getLine. And getLine gets assigned the f stream in. So we use this one, and then a variable to save the line that it reads. So in this case, the line that it should read is just the P2, which is on top of our file here. And because this one is the file format, we can just use the image point operator format to save this one. And because we only work with this format, we should definitely ask if this is the actual format of the file. So we just check it with an if function. If image format is not P, then we have the output that the file format is invalid, and return image. Next, we can get the second line also with the getLine function. This time we won't get the format, but the comment. So we can just change this variable to comment. Okay, that's it. Then the next line, the third line, is very important because it defines the vector in which we later save all the gray values, because this is the size. So we get the rows and columns. For that, we use the f stream in, and then for the first number is the columns, so we just set this to image cols and put a small comment here that this is to read the image columns. And the next number, of course, is the number of rows. So we get it in with the f stream image rows. Next, we can have a test output to check the number of pixels. So we type into the output the number of pixels, and then we just take the number of columns and rows and multiply them. So image cols times image rows. Okay, because these values are important later for our vector for the gray values. But before we check that, let's read the maximum gray value first. So in this number right here, in image maxval, and in the next step we want to set our vector for the gray values. So we say image gray values, and to set this we need to set the size. So we type in resize, and then we can take just the product of rows and columns that we calculated here, and this should be the size. Let's put a comment here first. So this is to set the size of the gray value vector. And in the next step we can then read the gray values into the vector. And this is done with a for loop. So we can set the comment here to read gray values in a loop over all pixel. And so we start our for loop with an unsigned int I equals 0, and it should run until the number of pixels, which is just, as we calculated it, the product of rows and columns. So this one, and we set I++, and then inside of the for loop we can assign the values. So we go through every row and every column of the whole file, and to read in the gray value of the specific position I. And now again it is important to check if everything went smoothly. So we check the number of red values. So we do this with an if condition. We say if, and then our product of rows and columns, so should be every pixel. If this number does not equal the image gray values size, then we want to have the output that says couldn't read all pixels. And in the other case, so if everything was successful and the number of pixels is indeed the actual vector size, then we say else, and to know that it went alright, we just also put an output here that says that all pixels have been read. And again we need a return value here, which is the image. So now we have the function to read a Pgm image, and we can also test this, but we first need another file for this, which will be our main file, so main cpp. And in here we need our standard structure, so we first include the IO stream, and also it is now important to include the header file. and we want to use our standard namespace. Okay, then our main function, as usual, with a return value. And now we are all set to read our image file. Okay, for this we set a new variable depending on our data types, so simg img. And this img now gets values from the file which was named Victoria underscore ASCII. So just the exact file name. Okay, so we take the function to read our PGM, and now we can see already that the file name is expected in this bracket. So we put it in there, Victoria underscore ASCII. And now if we try to run this, then we can see some errors at first because the file is on the desktop and it needs to be put into the project folder. So I have to do that first. So we can take this file and we have to put it into documents, own documents, and then there's a folder called Visual Studio. And then we go into our projects and select the current project, read PGM, and right here we have to put our image file. So right there where all the other source codes are in, we have to put the image. So I'm gonna copy and paste the file into this folder. And now we can try to run it again. Okay, so now it's time to correct all these errors that we have here. For example, in this case, there's the wrong name for this. We should choose file name and save it, run again. We have another error here, missing a semicolon, and there's return, should be written like this. These are just the small errors that occur when you just try to code. It's very normal. Here's another semicolon missing, an end line. So just add this one. And now it worked. Okay, well, first I have made another error. This is P2, of course, because the output said the file format was invalid. But now, okay, so now it was successful. We have 390,000 something pixels and all of them have been read. Okay, so now this is our whole function to read the file, and please remember that the file itself has to be put into this folder of the projects from our Visual Studio. Okay, so next we have the function to read a gray value, and this is not as much as the read function, so because the read function was the most extensive one. So we set brackets for our function, and then first we define a variable called g, a short g equals 0, and now g is the image's gray value of a specific position. So, and now we have to think about this position because we saved all the values in one vector and not in a matrix, so we cannot just say R and C, but we first have to see which one it is. So the position we have to set here is in row R, but we have to multiply it by the number of columns. So image of culs, and then plus the amount of C we have as an input here. So, and then this is the exact position inside of the vector. But first, of course, we have to check if the coordinate that was given is inside of the image, because if not, then our function cannot find it. So we do this with an if condition that says if r times c greater than the gray values vector size, which then means it's not inside of it, we have an output that says r comma c and then is not an element of the image. Now we just need our return value g.
So.
And now we can try to run this and get the gray value information of the first pixel in the image.
Wir führen das Ganze jetzt nochmal aus.
First save and then we go back to main CPP.
Mit unserer neuen Funktion und wir wollen uns jetzt den Wert im ersten Pixel ausgeben lassen. Das machen wir dann wie folgt.
Get gray value
Ganz einfach,
of,
cout.
and then we have to assign the image and the row and column. In this case, the first pixel is 0, 0.
An der Stelle.
So we type in get gray value of img, comma 0, 0, end line, semicolon. Then let's see what happens. Okay, so the output says 139, which is the exact value, gray value of the first pixel, 139. Okay, what if we put instead of 0 a 1 here? Then the answer should be 143 because the second pixel has the value 143. So let's see, and the answer is 143. So just like this, and we can do this for every pixel we want to. Okay, so this works. Then the next step would be to set a gray value. For this, we go back to our other CPP file, collapse this, and we start the new function with opening the brackets. And this is going to be also a very short function. So first, we again have to check if the coordinates are inside of the image. So we can simply take the condition, the if condition from the other function, this part from the get gray value, and we can just paste it into here. But I noticed we forgot the return value here, to just set the return value g, because if this is outside of the image, g is 0, so the return value is 0. But in the next function, we don't have this return value g, but instead, if it's not in the inside of the image, we just return nothing. Okay, and to set the gray value, we use our vector gray values. So we just say that the vector image gray values at the position, and now we have to say this calculation again. So row r times the image columns plus the current column. So, and this should get the value that has been assigned to the function. So we just say val here. And now we can test it, but because we haven't written the save function yet, we just test it without saving. And to do that, we write a for loop. So for r equals 20, r smaller than 120, r plus plus, and inside this for loop we type in another for loop. So this one is for the columns, so for int c equals 20, c smaller than 120, c plus plus, and inside this one we just say set gray value, and then we have to assign the image img and r and c and 0, which is black in this case. Okay, so what does this short loop do? Well, it says the program should go to position 2020, row 20, column 20, and then until position 120 and 120, it should color this whole area black with 0. Okay. But before we can see the result in an image, we have to go back to our other CPP file and first write the function to save the new image. So to do that, we need an f stream again. So first let's open the function again with brackets, f stream, which we name file, because we're working with a file again, we want to save this. Then we open the file and we assign the file name, and we say that we want to open it for output operations, so we just put an iOS : and out. Okay, next we have to make the obligatory check if the file couldn't be opened. So if not file is open, then we set the output to cout and then quotation marks, couldn't open file, and then we can also put the file name here, couldn't open file name. Okay, so like this, exclamation mark, and if this was the case, so couldn't be opened, then the return value should be -1. So we return -1. Okay. Then we have to write the whole file. So, and we want to orientate ourselves by the given file format. So we first have to say file P2 because we want to keep the format P2. Next is the comment, and in this case we want to say that this file has been generated by us. Okay, this should be fine. Next is the size, so the number of rows and columns. Here we can just put cols and rows, but with a space in between, so image cols, and then in quotation marks a space, image rows. In the next line is the maximum gray value, so we just set the max val. end line, and then the only thing that's missing is all these gray values. But we have to remember that we have line breaks in this file at some point, so we have to be careful when to set a new line. Okay, so we do this with a for loop, but this time we don't take one but two control variables. So we say unsigned int I equals 0 and j equals 0. Then we say as long as I is smaller than the number of pixels, which is calculated by the columns times the rows. So image rows times image cols. As long as this is the case, then increase I and increase j by 1. Okay, and inside of the loop, here important is the comma and not a semicolon. Okay, inside of this loop, we write into the file the gray value at position I with a space, because we have a space in between all these gray values. And if j equals 16, so this is for the new line, which says that after every 17 values we set a new line, then write just an end line and we get a new line. So, and because if we set now j equals -1, this means that in every iteration j is being incremented by 1, and so j is 0 again. The return value is 0 because also for the function we use the return value integer. And here we directly write into the file, so we don't need an image as a return value or as we'd have done it before. Okay, back to the main function. We remember that we color this area between rows 20 and columns 20 and 20 to 120 all in black. And to check if that was successful, we use the function that we just wrote, write Pgm. And we need the image for that. We need a file name that is assigned as a string. So we just say here test.pgm. Then save this and run. Okay, so the run seems successful. There's no errors. And now we can look into our folder. So go back to the Explorer and then go to Visual Studio Projects, the current project read Pgm. And in there, there's a new file test.pgm. And we can see that it's not empty, so something has to be written in here. And if we open it with our text editor, then we can see that the format seems okay. We have P2 and all this stuff up here, and then all these gray values. Every 17 values there's a line break, and this looks good for the whole file. And if we now take OrphanView, our image viewer, and open the old version in here, then this is just a reminder how it looked before, and this is after. So you can see this black area from coordinate 2020 until coordinate 120, 120. So with the header, we created a user-defined data type to manage the grayscale images. And then we implemented a function to read the Pgm file. This one, then we asked for values inside of the Pgm file. This one was named get gray values, and another one was to set new gray values into the image, and the last one was to save it. So this is just a short example. Of course, there's a lot more you can do with digital images, but this is just what I wanted to show you, and I hope you got an idea how to implement all these functions, and I want to thank you for your attention.